Okay, let's take a look at vectors today. So the first thing we're going to do is take a look at using north and east and get those into degrees, because north and east isn't as useful when we're doing problems on paper. I guess they're useful when you're doing the problems out in the world, but not so much on paper because north and east are kind of relative. So we're going to look at a vector, and a vector is just a direction with some sort of magnitude. So lots of times we'll use velocity as a vector. It's a vector because you're moving at a certain speed, velocity, but it's in a certain direction because velocity is about direction. So let's look at 2 centimeters north, and then we've got 3 centimeters east. And what I'm trying to do here is actually figure out what is my vector for it. In other words, if I add the two of these. So really, I'm going to take my 2 north and put it over here. And think of it in this sort of way, as a triangle. If I take my 3 east and add it to my 2 north, I'll get this direction overall. That'll be my displacement. And so I'm wondering, what is that value at that spot? So when I'm going to do that, the first thing I need to do is figure out the length. So finding out the length, a squared plus b squared equals c squared. This is all trig right here. So I'm going to call my a squared my 3, and my b my 2, and my c squared is my hypotenuse. So I'm going to do some math. 9 plus 4 equals c squared. 9 plus 4 is 13. The square root of 13 is 3.6. C equals 3.6. That's my length. Then the other part that I need is to find my angle. Here's my angle, or my theta. So I could use many different ways to find my theta since I have all the sides of the triangle, but it's best to use tangent. And the reason for that is tangent is opposite over adjacent. And those two values are given in my problem, so I didn't have any sig fig kind of issues. So those are the more reliable ones to use. I could use this 3.6, but I had to do math and round there, so it's less precise. So here I'm looking at the tangent of theta is equal to the opposite over the adjacent, which means tangent of theta is equal to 2 over 3. Hopefully you can use your calculator to get your angle here. It's 33.7, or I'm going to round to 34 degrees. Make sure your calculator is in degrees and not radians. There we go. So then in the class we did a second one kind of together. If you think you know what you're doing, give this video a pause and come back and check the answers, but I'll talk about it real quick. So looking at these, we've got our north, south, west, east, and we've got 2 centimeters south, so 2 centimeters south, 2, and then 6 centimeters west, 6 centimeters west, 6 west. I drew it this way this time, that way I can do like the tip to the tail. In other words, this arrow tip is now at this arrow's tail, tip to tail method it's called, and we're going to do that a little bit more. And now I want to find what is the length of that side. Taking a look at that side length, I'm going to do a squared plus b squared equals c squared again. So 2.0 squared plus 6 squared equals c squared. If I do all that math, I get c to equal 6.3. And then the last thing I'm trying to do is find the angle. So the angle I'm working with is going to be right, whoop, I'm going to do a little bit different here. Sorry. You could find it in a lot of different ways here, but I want to show you how we're going to want to do it in physics. So the angle that I'm really going to want to find is this one right here. So I'm going to kind of redraw it. This is my kind of arrow. I want to find this angle right here. So in order to do that, my going down one is the 2, that's my south. My going to the left one is my west, or my 6. So I'm doing the tangent of theta is the opposite, which is 2, or the adjacent, which is 6. And in the end, that gets me my theta of 18. 18.4 really, but I'm going to call it 18. Doing 2 sig figs here today. Now the reason I want that one is because that's not the actual final answer. What I really want to know is what is the angle all the way from the start to the end there, all the way over. I could have done it with the other angle, with this one right here, but I kind of choose to do that one because it makes more sense to me. So you could go either way. Either way you look at it, let's kind of figure out what that angle really is. This is 0 degrees on the whole quadrant. This would be your 90 degrees. We're going around the circle here. This is your 180 degrees. This one over here is 180 plus 90, which is 270 degrees, and then it gets us back to 0. So when I actually want to find this whole angle, because that's my actual vector, my vector is in consideration from right here. In consideration from that center spot, I'm going at a magnitude of 6.3 and an angle of 180 plus 18. I'm going 180 plus that extra 18, which equals 198. So my vector would be 198 degrees, 6.3 in magnitude. Alrighty. Now that we've got that basic kind of trig, this is mostly the kind of math you're going to need in physics. The tougher stuff that we're going to do later on with math, here it's not very often that you actually have to do it, but this is the main stuff right here. So let's look at adding vectors tip to tail. I'll make this kind of brief. So I've got time for my big problem. So let's say you've got a vector, and this isn't going to have any angles and such. A and B. Here's A and here's B. Let's say I wanted to add vector A plus vector B. What would I actually get? When I'm going to add A plus B, what I am doing is actually taking them tip to tail. So I'm going to take A here plus B. B is going off this way a little bit, B. So I'm adding them tip to tail, where the tip of A is now connected to the tail of B, so that I can see my resultant vector. My resultant vector is this green line right here. This would be A plus B. And so that's the vector that we're going to be solving for eventually. And it has this angle, and it has that length, whatever that might be. Okay, let's look at a different one. So in this case, if I want to do A plus B, put in my quadrant together, my A will be this little guy here, and my B is going to go tip to tail on that, whoop, over here, right? It gets a little funny then. So that my resultant one is actually from that start up to wherever it ended here. This is AB. So again, when I'm going to find angles, I'm going to really find this angle right here from the start to the finish, as well as the distance. And we're going to do that with actual numbers in a second. You can do A minus B kind of situations. So let's say we've got something like A again, and B here. So then my thing would be, what is A minus B? Well, when I'm looking at A minus B, I'm again going to put in A. Here's my A. And then when I'm thinking about B, my B, a minus B is just flipped over like this is a mirror that's just flipped over on it. And so this is my minus B vector. So a minus B added to that part is like this. So it's kind of like I'm doing A plus a negative B, because A plus a negative B is the same as A minus B, which means my resultant vector is going to be this one right here. Now we're not going to do minuses too often, but that is how you would do them. Okay, we're going to be looking at adding these specific vectors. So thinking about, oh dear. So thinking about up here, this A has a magnitude and a direction. In other words, it has a number that goes with it, like 2, and a direction like 13 degrees. B has the same thing. It might be 100 degrees and a magnitude of 6, something like that. So now I've actually got that in this case. A is 20 at 230 degrees, and B is 6 at 160 degrees. So my job is I'm going to add these two up and actually figure out what is the end resultant. So I kind of like to draw it first. Here's my A, 230 degrees. Well, this over here is 180, and this is 270. So 230 to me is like here-ish. Here's my A, the magnitude of 20. And this angle right here is kind of what I want more. So that angle there is going to be my 230 minus 180. 230 minus 180. Come on. 50, right? 50. 50. That's the angle I'm going to really want, because that's the little mini triangle I'm going to work with. I'm adding it to B. And B is 160. So that's going to be something like this. I should make that a little bit lower, because 160, that makes this 20. That's B. So when I put them together, I want to have A is going to be pretty long, right? And B is going to be not so long. A plus B. Something like that. So this is my resultant vector right here. That's what I want to find, that green thing. Oh, I shouldn't go that long. Sorry. Just go to here. All right. So really I'm trying to find this angle right here, and then that length of the green. That's my whole goal. But in order to do that, I've really got to do a lot of steps to it. In other words, what I'm really going to solve for is how much does this green arrow go to the left? That'll be its x value. And how much does this green arrow go down to the y? That'll be its y value. So I'm going to find each part separately, and then from that I can find my green arrow. I can't just use my triangles right here and just like I did before. I've got to do a lot more math with it. So when we do this, we kind of set up a table, and he'll do this in the textbook in the end part. And you don't have to set up a table. He really doesn't in the textbook, but I find it to be a lot easier. So it's got like a pattern to it, and that tends to work out better for me. Okay, so what we're going to do is solve for what is the x part of A, and then that'll go in this box down here. And then what is the y portion of A? B and x. So what that's kind of saying is, when you look at the A vector over here, how much of it goes down in, to the left in the x direction, and how much of it goes down in the y direction? That's what we're saying. And then we're going to take this value of its x, and then this value of his x, and we can add them together to actually get what the resultant x is over here. We're going to take each piece of A and add it together, and each piece of B and add it together to get x and y. Let me show you what I mean. So we're looking at A here. I need to find how much does it go to the left. That's my x side. So if I think about it as a triangle, going to the x side, that's an adjacent. And I also have the hypotenuse, which is over 20. So if I have adjacent over hypotenuse, that's cosine, which means cosine over 50 is going to be my adjacent one, call it adjacent here, over 20, which is the hypotenuse. Now, calling it adjacent is probably the best way to call it. So what we normally will call it is A sub x, meaning A's vector in the x direction. A's vector in the x direction, when I do all the math, is 12.9 on my calculator. Now we got to be careful though, because actually we're going to the left. To the left means negative. Your calculator is not going to spit that out because he doesn't know where you're drawing your triangle, but you just have to use your head to know it's in the negative direction. So let's do the same thing on B. I want to know how much is B going in the x direction. Again, we're going to be looking at adjacent over hypotenuse. My hypotenuse is 6. So I'm looking at cosine. But this time it's not cosine of 50, it's cosine of 20. And so again, adjacent isn't the best way to put it. It's really the B in the x direction. So B sub x is equal to 5.6. And again, I am going to the left. That's a negative, so I've got to call it negative. My calculator won't say that. I've just got to use my brain. And then what we're going to do is actually take this A value, negative 12.9, and add it to the B value, negative 5.6. And that's our resultant here. That's negative 18.5. That's how much it goes in the x direction. Okay, let's do the same thing with y. In other words, when I'm going in the y direction, I'm looking downward. How much does it go down? That's opposite of my angle. So I'm looking at opposite over the hypotenuse, which is 20. Well, I know that sine of 50 is opposite over 20. Or in other words, the way to say opposite would be my A sub y. A in the y direction. A in the y direction is negative 15.3. Sorry, you won't get negative. That won't come out of the calculator. But I know it's negative because I'm going downward. Downward is going to be negative, and to the left is going to be a negative number. So those are the negative quadrants. So negative 15.3. Same thing happens over here. I'm just going to dump in sine of 20. And it follows this pattern. When you want to find x, you're going cosine. When you want to find y, you're going sine. So here we go. Sine of 20 is b sub y over 6. So b sub y equals 2.1. Then I use my head. Do I want a negative or positive 2.1? Well, it's going upward, so I want a positive 2.1. Which means